Hi, I'm Megh Soni, and my component for this project focuses on data protection and encryption in a financial services environment hosted on AWS. The goal of this component is to ensure that all sensitive financial data, such as transactions, personal details, and account information, is fully protected against unauthorized access or disclosure. Encryption is critical because even with strong access controls, data can still be exposed through vulnerabilities, insider misuse, or configuration errors. My design outlines how encryption, key management, and tokenization work together to secure financial data, both at rest and in transit, while ensuring compliance with key frameworks such as the APRA CPS 234, the PCI DSS v4.0, and the Privacy Act 1988. So, encryption at rest. So, the first part of my design focuses on encryption at rest, which protects data stored in databases and storage services. All RDS instances, EBS volumes, and S3 buckets are encrypted using the AWS Key Management Service with custom managed keys. Databases use TDE, which is transparent data encryption, while storage uses AES 256 encryption with server side encryption, which is KMS. Bucket policies can also block any unencrypted uploads. These configurations ensure that even if an attacker accesses the storage layer, the data remains unreadable. This directly supports compliance requirements under PCI DSS as well as the Privacy Act, which both mandate encryption of sensitive information at rest. The second layer of this is encryption in transit. So this protects data as it moves between services or users. I used AWS Certificate Manager or ACM to issue and manage TLS 1.3 certificates for all load balancers, APIs, and endpoints. TLS 1.3 ensures strong encryption, forward secrecy, and protection against downgrade attacks. In practical terms, this means that all communication between clients, servers, and AWS resources are all protected from eavesdropping or tampering. This is vital in the financial sector, where unencrypted transmissions could lead to data leaks or regulatory breaches. So, to further secure more sensitive information, such as credit card or bank account numbers, I propose using tokenization. So, tokenization replaces real data with non sensitive tokens, meaning that even if another system is compromised, no raw data is actually exposed. For key management, I used AWS Cloud HSM, which stores encryption keys in hardware security modules. This meets both the ISO 27001 as well as the IEC 27001 and the PCI DSS standards. I also proposed key rotation policies so that cryptographic keys are refreshed periodically. This combination of tokenization, hardware backed key management, and key rotation reduces the risk of long term key compromise. So, a major challenge that we had during this project was understanding how AWS encryption services interact, specifically when to use KMS, Cloud HSM, or ACM. To overcome this, I reviewed AWS white papers, documentation, as well as the cloud practitioner training materials to clearly define their roles. Another challenge was balancing strong encryption with usability and cost to ensure that the design actually remained realistic and implementable in the real world. If I had more time, I would extend the design with AWS Macy for automatic detection of sensitive data in S3. And then I'd use AWS Backup for encrypted disaster recovery and Lambda functions to automate key rotations and compliance checks. So the key takeaways that I've gotten from this project is this project has given me a deep understanding of how encryption underpins trust in cloud environments. I learned how to translate theoretical security requirements into AWS-based technical controls, even without hands-on deployment. Compliance frameworks like the APRA CPS 234, the PCI DSS, and the Privacy Act guided every design decision. Overall, I gained the confidence to design data protection architectures that are secure, scalable, and compliant for financial institutions migrating to the cloud.
Hi everyone, my name is Kabir Panchal, and this presentation covers my component for our group project, Securing Financial Services in AWS Cloud. My focus is on identity and access management, or IAM, the foundation of cloud security. Over the next few minutes, I'll explain how IAM roles, multi-factor authentication, and centralized governance help protect financial data, which ensures compliance and strengthens AWS security overall. This slide introduces my topic, identity and access management in AWS Cloud. The goal of IAM is to control who can access what within AWS and ensure that every user or services only operate within approved boundaries. In financial services, that's essential to prevent fraud, insider misuse, or accidental exposure of sensitive data. My design focuses on ensuring least privilege access, multi-factor authentication, and central governance using AWS organizations and IAM Identity Center. These measures also ensure compliance within frameworks such as APRA, CPS 234, PCI DSS v4.0, and the Privacy Act 1988. The first part of my implementation focuses on role-based access control and least privilege. Using AWS IAM and AWS organizations, I created specific roles for the finance developer and compliance teams. Each role has only the permission necessary for its function. For example, finance can view billing data but not modify infrastructures, while developers can deploy code but not access financial data. At the organization's level, I implemented service control policies, also SCPs, to block high risk actions like disabling logging or deleting encryption keys. This structure enforces clear boundaries and satisfies PCI DSS requirement 7, which requires access to be limited strictly by business needs. This slide focuses on authentication and monitoring, which are critical to maintain control and visibility. I enforce multi-factor authentication or MFA for all privileged users to prevent credential theft. I also planned single sign-on, which integrates through IAM Identity Center, allowing staff to log in once securely across AWS accounts. For visibility, I use CloudTrail, which logs every IAM event for auditing and compliance tracking. Finally, I configured IAM Access Analyzer to identify any overly broad or risky policies. Together, these tools provide strong oversight and aligns with APRA CPS 234's focuses on governance and accountability. This slide outlines my implementation process and the challenge I faced. First, I set up AWS organization and applied service control policies to establish governance boundaries. Next, I created department-specific IAM roles and enforced MFA for all administrative accounts. Then, enabled CloudTrail logging and configured access analyzers for continuous monitoring. One major challenge was the AWS Educate environment, which only allowed a single account. To overcome this, I simulated multi-account governance within the single setup. Another challenge was policy precision. My first version were too broad, so I use IAM policy simulator to refine each one until they perfectly match least privilege principles. Despite these limitations, the IAM configuration worked as intended and was realistic for a financial organization. Through this project, I learned that IAM is about governance and visibility, not just policies. Even small micro configurations, like in the Capital One breach, can lead to data loss. If extended, I would add AWS Config and Security Hub for automated compliance and use CloudFormation to automate IAM setup. These steps would make the environment more scalable, consistent, and easier to audit. My component proved how least privilege, MFA, and monitoring protect financial data while meeting APRA, CPS 234, and PCI DSS. Even without full deployment, the test confirmed our IAM design is secure, compliant, and ready for production. Thank you so much.